How is chaos mathematics used in weather forecasting?
Have there been mornings when rain was forecast, but the sun was shining instead? Or times when the forecast said clear skies, so an umbrella was left behind, only for sudden rain to begin? People have long wondered, why is the weather forecast so often wrong? The answer involves a fascinating branch of mathematics, chaos mathematics. Weather is a phenomenon that occurs in the atmosphere. The sun is the main force that drives atmospheric movement. It heats the earth and creates different temperatures in different regions. When temperatures differ, air pressure changes. As a result, air moves and wind is created. When cold air moves down from the north, temperatures drop. When warm air rises from the south, temperatures increase. Water vapor in the air also rises high into the sky. As it cools, it forms clouds. Then it falls back to the ground as rain or snow. The problem is that atmospheric motion is extremely complex. Even at this very moment, winds are moving across the earth, oceans are storing heat, and water vapor is constantly shifting. Change never stops. So how do meteorologists predict such complex changes? Meteorologists collect data from around the world, including temperature, air pressure, humidity, and wind direction and speed. They feed this information into supercomputers to calculate future changes. Simply put, they use the present state to predict the future. But why are forecasts so often wrong? This is where chaos theory comes in. Chaos may look random, but it is actually a complex system that follows underlying rules. One of its most important features is sensitivity to initial conditions. For example, have you heard the idea that the tiny flap of a butterfly's wings could, over time, lead to a massive storm? This is the famous butterfly effect in chaos theory. A very small difference at the start can grow into an enormous one over time. The same is true for weather. Even a difference of just 0.1 degrees Celsius in the initial temperature can lead to completely different forecasts a few days later. On top of that, it is practically impossible to observe the Earth's entire weather system perfectly. The middle of the ocean, high mountains, and uninhabited regions cannot all be measured accurately. So, for places without observations, average values from nearby areas are sometimes used. But weather is a non-linear phenomenon that cannot be explained